Hello, everyone, and welcome to the broadcast. I'm newtmechanist, and we're going to be continuing our code project today. Been doing some digging at it, and you know what? We're back to looking at collision based on a compute shader instead of Godot. I'll get into the why shortly. I see Key's already here. Hey there, Key. Welcome. Check in with the kitties real quickly. Oof. Sherbet passing over my headrest. Amber is in her spot. Yes, hello. We have Sky up in the tree and Sammy and Mason down on the bed with Molly laying up against the TV screen. Let's see what's going right now. Bird feeders on snow. Molly, they all kind of take turns over there, whether it's just watching it or really taking a swing at the screen. But yeah, we used to have. So some time ago, I was trying to do brute force collision within a compute shader. And it was working okay, but there were a lot of things that I did wrong on it in hindsight, with knowledge acquired like months after we had abandoned it. So we're going to be going back to that. And well, here I can. So this right here is the problem. This right here is the problem. So we'll put this little guy here. Double check here just a moment. Yes, okay. So this is passage exited. This is you are coming out of a door. So it'll happen once when we start a level. Because I've got it wired up to essentially say to enter passage 1 is how the logic fires. So at the start of the level, we load the level, we start the level, and a level says, enter the first passage. And the first passage is supposed to dump you where you start. So we've entered the passage, so it will deactivate the current room or cause it to be deactivated. It will enter the new room, and now it's exiting the passage, exiting passage 1. Through whatever means. So we're going to have that resulted in the door. It says, okay, it's this room, this door is where I'm coming out of. This is the door that corresponds to that. So it is going to move the player around. Okay, so we've positioned the player. That happens once. Cool. Now I'm going to walk over here, and this red dot is the door. We slide forward and we touch that door. So we have entered a passage, we've left the room, we've entered the room, and now we're going to exit the door. It should put us right where we started, which is cool. So I'll press continue, and then the execution will continue and everything is good. And I do, but it didn't continue because it hit this spot again. And what this is exactly 1 frame later, the next physics tick that goes through, this collision happened again as a separate collision. If I were to look at that collision data again, the objects that are colliding are far apart. Based on everything that I can find, what is happening is that Godot sometimes doesn't get the prior state correct. So if I move physics objects around, sometimes it registers their last state for an extra frame. So if I tell it move to the right by 1 from 0, where I'm thinking, okay, it's going to be at 1, 0. Well, as far as the next physics calculation, it might still be at 0, 0. And what that's meaning is that in the next frame, it's saying, well, the player hasn't left the door, so they collide with the door again. could I correct this directly? Yes, I could, but this means that it is technically happening everywhere. That I could be getting aberrant behavior that is subtle, and I'm just not noticing it because of this. And that's a problem. That's a substantial problem. And I have been digging at this and digging at this. Here, let me remove the breakpoint, and you can see what's going to happen is I'm going to touch this, and it's going to, like, flicker. You will see almost like it appears here and here, because it's moving twice back to back. And it's making everything kind of jerk around. And we don't want that. We don't want that double frame movement like that. So, what does this mean? Well, our current collision system, the incredibly concisely named Physics Server Collision Manager, and the Physics Server Colliders, aren't working for us because they are reliant on Godot's underlying physics handling, which isn't bad. The only reason it's a problem for us is that we are trying to tighten everything down to the level of performance that we want to get, but that we also don't have shortcuts that we can use to avoid a lot of these issues. Since every bullet, every entity on the screen is a distinct thing, it can move in its own way, it has its own health, all of those, we're having to keep track of the way that they move around differently than we could if it was just a standard kind of bullet hell scenario where all we care about is this type of bullet is being emitted from here, this bullet started here. Which means that given a starting point and a behavior for a given bullet, in a lot of bullet hells, you can just say, well, if I set the time 3 forward, I know exactly where it is going to be. So I can make calculations based on that point anytime I want without having to know where it currently is precisely, because I can just consult the algorithm. In this case, we have no idea where it's going to be 10 seconds from now, because it could have behaviors in it that say, hey, after 9.5 seconds, do something completely different. So we can't advance calculate that. So we're spending extra time in the logic, and because the movement can be so fiddly, we also need to make sure that the collision is being handled properly. So that's why we're going to be digging a little further here. Now, have I messed with compute shaders since the last time? No. So it's going to be tutorial town again. Let's pull up that shader. I have to remember where I put it. I think it's in rendering here somewhere. It is hiding out somewhere. I'm trying to remember where I put this thing. That's how long it's been since I touched it. It's not a helper. Is it even in the GLSL? Let's take a look in Godot. Double checking, making sure all of my dials are set properly. Oh. All right, where did I hide that? I might have to explicitly include it somewhere. I know that there is a visual shader hiding around somewhere because the outline that you can see around the player, the red dot, actually, the red dot is also a good indicator. So the black outline around the player and the mice is entirely because of a shader that is placed on the object. Without that shader, it's well, they don't have an outline. They don't have that black outline around them. I did that in case I decide I don't want the black outline, so that I don't have to change every frame of every animation of every sprite every time I change my mind. Where did I put that? It's not a message. It's not clearly not part of the screens. It's not part of the rendering then. Would be part of world state. Oh. The 10th stream in a row on the Twitch side there, Geek. Thank you for watching. It's not a JSON helper. It's not a Godot helper. Okay. Is it just hiding entirely? Oh, wait. I can find it. I can find it. Entity visuals. Rendering. Entity rendering. Individual node rendering. Shader material. Okay. Visual shader, where are you coming from? Yeah, this is one of the things that might end up changing heavily down the road, but we'll get there. I don't have an interface for this yet. Okay. There's got to be a place where we populate it. In our startup resource. Export it. Tells you how frequently I've touched this. Okay. All right, and where is this hiding? Rendering, entity, individual nodes, shaders. Okay, but that doesn't appear as part of this project because it doesn't contain something that the Visual Studio side cares about. I might be able to incorporate that, but we need to be cautious about that because Godot does this itself. This is the Godot shader language is kind of a spin-off of, it's like, what was the file? So it's Godot shader, it's like GLSL or something like that, is a kind of standard shader language, with Godot having some variations on it. So this is a visual shader, and what this is going to do is every time the texture for an object, whenever the canvas for an object with this material or with this shader attached renders, it's going to do this. And what it's doing is it's looking for it's looking at the pixels immediately surrounding the current pixel and saying if any of them are not transparent, then it gets an outline. So we add in this shadow color here, which creates that dark outline. We are going to take that kind of pattern, or we're going to be doing this sort of calculation for, we're going to be using a thing like this. But part of it is going to be refreshing our knowledge of what we do here. So the first thing we're going to do is just get the shader running so that it does a thing. We just want it to execute, and we want it to do so in the sequence that we're going to be doing it in. The plan is that at the end of time passed, or at the end of the game step, essentially, when we are done with the current step, we are going to tell the physics server that it can start going. If we look at, I can show some examples of what's actually going on here. Screen game entity, which is down here. So we're going to do, it is going to be one of the on world end step. So whenever we do an end step, if we're active, we are going to move where we're configured to move. We're going to update the animation. We're going to clear out the movement that we had, and we're going to relay this end step message into like our behaviors and the like, health behaviors, all that stuff. So this is when the actual world is done. It is after the world end step currently that the physics would have to kick off. Can't be during this, it needs to be after this. Which would be, if we look at game, so this is a full tick. So the world simulation is going to go through and say, okay, I'm going to do a game start here, and then I'm going to do a game time passed. So even if we are paused, even if we're not doing a new physics tick, we are going to do game time pass. So this is primarily for anything to do maybe with the UI or something that is not part of the in-world simulation. That's the game time passing. Then if we're not paused and enough time has passed for a fixed tick, which is only relevant if the game is running slow, if our computation time per frame is getting too high, that will come into play. But once game time has passed and we have a world step, we're going to do start, physics, time passed, end. So start is just the clear everything out and get ready, or get ready for the next round, essentially. Physics is process the results of everything that happened in the last set, all the movement that happened previously. So if the way we moved ended up causing a collision, so, I took a step forward and bumped into something, the fact that I bumped into something is part of the results of that and is processed in physics step, so that information is available as we pass into the next world time passed. So if something is going to get disabled, if some modifier to its movement is going to be applied, we're going to find out during that. There's nuance in there, but we get time passed, we get to the end step. End step is where we apply the results of everything previously. So it's primarily any sort of movement that happened is what we apply there. But other things can take that same pattern. Is end step should be finalize the results. We get through those messages, and then we say game end step. Game end step is going to be where physics says, okay, I have all of the information. Everything is finalized. I'm going to take all of that information and start processing it. We're then going to get back up to the top of the loop here, go through those and say, hey, the next physics step happened. And until we get to that, the game end step, hey, I need to kick off physics, doesn't happen. I might need to add another step at the end here. So this is the end step. which is everything wrap up. But again, I can't do the physics there because that is everything being finalized. Oh, man. That's right. And the reason that we wait, the reason that we don't just do that during world time past, is that other results could happen. Other things could influence our object during this. And we don't want to head it off. But thinking on that, we might be able to simplify it and use end step as a assume everything is done and ready. Okay, but regardless of where we put that, regardless of any changes I decide to make based on this thought that I'm running through here, we will start the processing of a compute shader somewhere down here. Then when we get back up to the physics step, we're going to look at it and say, okay, give me the results. We may cause it to wait longer, but even given the amount of work that we're asking it to do, it should be able to do it within the next frame update. And if we're removing the built-in physics handling of Godot, that should save us a lot more cost, because we're not having in the background Godot's thread say, okay, wait, or, I'm processing all this, here are all these events coming in. And we're also not dealing with those extraneous events. By giving it a full frame, there's also a decent chance that because it's done, we don't cause the graphics card, and the GPU and the CPU to have to do a sync up, like a hard sync. So we'll see there. So again, there's some nuance to this as to exactly what is the kickoff point and when do we get it. If the kickoff point is not in the world end step, we need to make sure that there is logic to say, I'm still waiting on a result. Actually, there will still need to be logic for waiting on a result. There will need to be the next physics tick is ready. Because it doesn't matter if enough time has passed for us to do another frame. If I have not yet caused another one to go through, then it doesn't matter. That may be a moot point, though. It's more relevant if I kick off physics here. Because if I don't read it inside of a world step, it doesn't matter. Did I add the Windows 95 Maze screensaver shooter section yet? I remember... Yeah, I think that's the one you're referring to, is the sort of old 2.5D style, Wolfenstein Doom style maze navigation. Could be a cute little thing there. One of the games that is the precursor to Metal Slug, which is what I think about when I think of the way that I want the level, like the room navigation to flow, is that I go to the, like, if I go to this part of this particular portion of the level, that transitions me elsewhere. A precursor of that kind of game is a run and gun platformer. Like things like Contra. And in the original and onward Contra games, most of the levels are side-scrolling, but there were some kind of top-scrolling almost, but it was a pseudo over-the-shoulder shooting, third-person kind of thing. And that could be another way to present some of these, is that there's nothing stopping a room from being a vertical room that creates the false impression of movement into the background, like depth-like movement. Fiddlier, yes, but possible. But in any event, welcome, Lunar, welcome. Okay, so we need to set up a compute shader. So I've got the documentation for this again. That's what we're going to be referencing. There's a lot of stuff that we'll be doing. So we're going to make a shader where we're going to end up defining our things like shader layout, and that's how it breaks up the work across all of the cores for the GPU, or how it breaks up work for the cores to approach. The sizes X, Y, and Z are effectively a nested for loop. So for X is, 0 to number inside that. For Y is 0 to number inside that. For Z is 0 to number. And you do your work based on those three values. And though that job will be spread across them because the work that they're doing is mostly, not entirely, in a vacuum. They don't, the different parts don't really talk to each other. Or you try to avoid it. Because you don't want like a sync have to happen between them. Ruins some of the parallelism. So we'll set up what that layout is, as well as data coming in. Data buffer is something that we're going to need. So right here, what they're doing in the sample is they're saying, take all of the data that I receive, and I am going to take each float value in that and double it. And then when they get that back, they just read them out. This is their sample logic. There's a lot of fixed prior knowledge going on here. Back cough. Air's a little dry, so sorry if I get raspy. So right here, what I was mentioning. So the local size X right here. So within it, and then you can also have work group size. So it can nest in nest in nest in nest. So your local size here is that's like one bank of them. Then the work groups are the fully parallel ones. Again, buffer is our pass in, pass out stuff. You can set it up in a couple of different ways. We're going to start with some of this logic here, which is we're just going to kind of brute force this stuff in. Again, we're going to build this into the current physics system in parallel. Largely because I don't want to break everything outright. Or I guess another way to put it is we will be creating a different device and registering a different service during this process. Saves us a couple of things. Is one, we don't have to do heavy branching as long as I don't wreck the existing structures. But we'll go from there. So the data is going to be one of those places that we need to be very cognizant of as we're loading it here. Is that we need to make sure of how much and in what format we are pushing the data. Data that reaches the shader needs to be in particular formats. It expects particular sizes in particular configurations. At least on the Godot side, it wants clusters of 4 32-bit floats. in size. That is like a chunk of data. So 128 bits is the sort of chunk size. And those are allocated based on effectively structure configuration. So the order in which the variables are set up in your data is important here. So a lot of the data that we're going to set up, we're just going to be going with the flow here and saying, yeah, it's 4 floats in a row, and we shape it accordingly. Anything that we're dealing with has to be in that sort of structure. That is, we want it to be in exactly this configuration that will be of optimal ease of use. Oof. So we can see some of that here. Let me just... Here. So, like, oh, I have this array of floats, 1 through 10. So then I'm converting it into bytes, into, binary code of that whole array, and saying now it's an array of bytes that is I'm creating an array of bytes that is the exact byte length of that array. So how many floats, the size of the float, that's how many bytes. And then we copy the memory that this array points to. This is, I've mentioned before that while I wouldn't advise anybody learn to program like as their first, I want to get into programming language B, C++, there's a point in sort of your journey as a programmer where learning the way that you actually interact with memory that C++ often requires you to do, in general, requires you to do manually, unless you add some extra like libraries in, is good to know. And that's what's happening here is these variables are not this data. This variable is what's called a pointer to, an address of this array. In C++, if I were to say, I can essentially say, what is at this address? What is at the address of input? And what is at its address is this number 1. If I were to say, what is at the address of input plus 1, that would be 2. And so on. Because this is a pointer. This is a reference to. So when I'm copying stuff, I'm saying there is some data that starts here and is this long that I want to copy. And so it starts here. This is where we're putting it, and this is how many bytes to copy. Then we're going to take that, and here is a notable one. So that's what I was just mentioning as far as what it wants. So we're creating that storage buffer, we're putting that there. So we're saying, okay, exactly this much, an unsigned integer that is, this is how many bytes we have just put in there. And the data that we're putting in there. And it's, so because we have made this a 32-bit float, we have this 40 bytes that were loaded, but it's knowing this sort of layout, knowing how we are configuring things is going to be important. One of the things that hung us up for a while on the first one was we had to change the order of one variable within the structure that we defined to house our data. And that altered the whole thing. Not an algorithm, not any sort of calculation or way that they interacted. It was that that value needed to be below this value in the structure. That was the critical change. Did it change anything anywhere else? Not really. So we create that, we stuff that in, we get it ready. Uniforms are a type of data. We need to make sure, I think storage buffers is actually what we want to be using. But we'll need to be certain here. We'll have to dig further into some of these methods and samples to get that. I might have to dig up some more as we go along today. Don't know if this will help us, but let's take a look at their sample here. We'll have to see where it loads it up. It's 2 images. That doesn't really help us here. What are some other nuances? Things like restrict. There are ways that you can set up the data such that you could refer to this same pool of data by different names in different places in Logic. Like you could share it across different shaders, that kind of thing, or different portions of Logic, fiddly bits. But what that's saying is, no, this declaration, this particular variable name or variable is the only one that refers to this memory. It changes the way that the GPU is going to handle a lot of this stuff. But you can set up read-only, you can set up read-write, all of that different kind of stuff for these. So, like image store into height map, this stuff is effectively the output variable, or where they're going to get their results. This is something that they use to process it. I talked before about how we're going to set up walls and floors. We're going to be using the same kind of pattern. The difference being that we won't have to run that one constantly yet. Since we're moving to shader-based collision, that might be part of the update process, is that we update that so that it's ready for the next time passed step as well. But yeah, let me check something real quick here. Yeah, all right. Let's just dive into it here. Just going to be a void main. So what do we do for this? We are going to make a new folder for collisions. Oof. Check. Okay. Oh, it's going to be a service. It's going to be a collision node. It's going to be this. We're going to add a folder. And it needs to be a physics server collision manager as an extension. No, I'm sorry, a collision manager. And we'll just use the core namespace. It's public class. It is going to extend collision manager. That's right. Some of that is going to change. Collision Manager does not need to be a node. Like right now, it extends node 2D because of the way things come along, but it doesn't actually have to. We could have ways of getting the stuff into the system that we don't otherwise need. And that will change if this ends up being the way we go with it. We'll just declare that the floorboards have been well and truly ripped up. Sure. Okay. So we need shader file. This will be constant for now. So the path to it. Again, we're going to lock that in place for now. But longer term, it will live elsewhere. And we will load that in accordingly. Likely that is something that we're going to pull in the catalog process. But we'll see. Okay, quick break. I will be right back, and then we'll be back to it. And back in we go. Okay, so we need the shader file. Let's go into the Godot side. And we have collision, compute shader. We're going to add due to add one. There was a do we have that in the tutorial here? Can I just do it from this editor? New shader. B. Okay. Get heavy tutorial work going on here. I really hope we don't have a documentation mismatch here. Welcome to a decent part of coding is looking at documentation. Programming is one of those places where people will sometimes give you the impression that you're supposed to memorize everything or know everything up front. And if you know it and can just keep going, that's fantastic, but don't delude yourself into thinking that you're going to know every nuance of every circumstance that you'll ever encounter and be able to just quote it from memory. If for no other reason than your memory might be wrong, refresh yourself, verify what you're doing. Check things. That's why autocomplete and whatnot can be useful, is it will give you indications. Things that, hey, that doesn't line up, you know? Oh. We're using compute, so we have to pop out of compatibility, so we're popping out of potato mode into have to use mobile or forward plus. Forward plus is effectively use desktop. Let me see if their example. What do we mean unknown directive for that? Is it just a formatting issue? Nope. Let's just gonna pop this in here and verify. Okay, it still doesn't like that it starts with that. What is missing? Okay, we're gonna go another route here. That's why. Okay, we got this. We're gonna add it over here. Oh. Add new. New item, and this is collision. We are going to need to find a good way to locate these and identify them, but we'll see. Because I want to figure out a way to actually parse these out of the file folder and locate them so that I can reference them by like an identifier instead of having to either connect them to Godot resources or use magic strings. Even setting a constant in that scenario is kind of a hassle. But for now, it'll be what it'll be. Okay, so then we can go into scripts here. Come on now. That should be... Okay, that's right. We are kind of, how to put this? Doing this kind of puts us in the wilderness. Because on the Godot side, we will be needing a main here. Here's one of your fun Holy War things. So here's a curly brace on the prior line. I like to do this. I like to have the braces on their own lines, encapsulating the thing, such that the title is always separate of it, like a full line separated. But some folks like this instead, where the curly brace is on the same line. And so when I'm looking at it, I'm looking at this is essentially the delimiter that starts it, as opposed to this is the thing that is the header of the encapsulation, and below it is the entire encapsulation. It's kind of a preference thing. But like number of tabs in a number of spaces that is equivalent to a single tab, if you want to have a knives out discussion with some veteran programmers, pick a random number that isn't like 3 and declare on Reddit that the optimal like way to do it is 4 to 5 spaces or something like that. And prepare for death threats. Everybody has an opinion on that, and a common thing of dealing with it is within a particular development shop. Everybody agrees on the rules. This is how we're going to do it. This is how we're all going to play nice together. I have seen it to be anything from this is the rules book for our code base, all the way down to each team gets their own rules. If you are touching another team's files, you follow the rules that are illustrated in that file. Anytime you touch a file, you don't mess with those rules. If the tabs are 15 spaces long in that file, they're 15 spaces long when you're done making your edit. It's again, how we all play nice together programming convention. There are limits, but it saves a lot of bloodshed. Okay, so we have our layout marker. So this is, again, how it will break it out within a work group. We won't be doing all of this same stuff, but this we are going to be preparing for. In this case, we're saying there will be a single execution within a given work group. Molly is sitting on my lap and soaking attention. He's a big sweetheart. She is also the one that will steal my chair. If I leave for just long enough, she will have claimed my desk chair and I have to move her. And she's always... It's not that, like, cat indignant. It's more of a, hey, wait, what happened? I was comfy. Often I will try to just pick her up and then sit her on my lap as I'm situating. Almost every gaming stream is in some part an Ember, a cat gaming stream. The primary exceptions are Mason and Sherbet. Everybody else interferes in some fashion. Back scratches for Molly. Oh, I see we have a delayed notification raid from Alkaline and Company. Hey there, folks. Welcome, welcome. We are moving a little bit more slowly in the code today, but that gives us plenty of time to chat and for me to reassess what I'm doing at each stage, because we're getting into some fun territory. But yes, welcome, and thank you for the raid. What were you folks just doing over there, Alkaline? Giving a kitty cat back scratches right now. And she is deciding whether they are acceptable. Oh. Block breakers are fun. Actually got... Ball X Pit was an amusing exercise as far as recent games. It's fun seeing people take a genre and do a spin on it, you know? You know, what if I made one of those except kind of things? Sometimes except can just be, but it uses this kind of color palette, or using this art that I like, or this theme that I like. But sometimes it's with this cool spin that I thought up, and you get things like Balatro and whatnot. That sort of, who would have thought game design? Oh. So what we're doing, for those of you joining us, is we're looking at returning to the idea of collision detection being done by brute force inside of a compute shader. And we are doing this because the way that Godot physics works, if we want to keep the performance, we can't use Godot physics bodies. And if we're not using bodies, then and the movement simulation according to those, then we would have to use areas, which are more performant. But areas also have the same problem, that if you move them manually, if you set their positions instead of having Godot physics body simulation executed on them, then the physics calculations can be more than one frame out of date. So I could move an object in frame 1 as a result of a collision that happened in frame 0, or that was calculated at the end of frame 0, and move it out of collision range, but frame 1 will also include a new collision with that, or the subsequent frame. So original collision on 0, frame 1 says move it away. I get to frame 2 and I have another collision with the same objects despite them being far away from each other in the data. So we're just going to avoid that entirely. But we can't do that inside of raw code because we're talking like 10,000 objects potentially colliding with 10,000 objects. And that would be a problem. So we're going to let the GPU do it. But as might be indicated here, that is a completely different language that we're effectively dealing with. And there's also a lot of fun little nuance that we need to add in there. Chin scratches for the kitty. Molly's kind of a big marshmallow. She has very little cat agility. She is naturally round. Like, even as a trim little kitten, she was kind of football-shaped. So now with a little indoor cat pudge on her, she is still... She's like pillow. She's a little pillow. But she also generates a great deal of heat and static electricity. Just her walking by, like if I'm just touching her fur and she moves at all, it can result in sparks. Which is why my mouse pad and similar is a big, like, electrostatic mat. Grounding wires everywhere. Okay. So we're going to create this, but to get rolling on that side, then what we're going to do is we're going to start loading it in on the Godot side. So we need our rendering device. We're going to have our shader, which we have our whole layer here. Let's see here. What we need to do is, one, get these things ready. They're definitely not going to be in variables. They're not going to be in vars. We're going to get each of these ready, but we need to figure out which ones are resources. Free memory. Okay. Buffer pipeline uniform set. All right. We're going to check each of these as we go along. Anything that has a Godot resource identifier, we need to know, because those need to be manually released when you're done with them. Once again, learning good memory management hygiene. Otherwise, you get memory leaks. We have some. I don't know where they live, but we have some of them. Okie dokie. Close everything else. And we have our shader collision manager. And since we are currently a node, we're going to use ready. I'm going to get this, and we're going to see what it's supposed to return. It's a rendering device. Okay, we make one of those. And a rendering device is a what? Static partial, okay. We have a GD load shader file. Now, interestingly, the shader files are going to be... Shader files probably aren't going to be, like, in the data folder. So I might have a separate entity that is, like, the shader catalog that has a different way of finding and loading the shaders. So ultimately, there might be a separate folder off of, like, instead of services or screens or messages, there might be a shaders folder with its own hierarchy that I can then sick a class on and say, find all of the shaders and give them an ID in the code. So get their path and get their file name or something along those lines, so that then I can have an identifier in files to say it uses this shader. For now, though, again, fixed. So it should be something... Yeah. So like resources / should be down to... Vision, compute shader. Typing around a kitty cat. Make picking a tile set easier. So tile sets are going to be a whole other thing that I might end up circling back around to again. But at the moment, we have largely set aside tile sets to just say, I will just make images of the maps. The nature of the game we're going to be working with is such that I can't really use a Godot tile map layer of any kind. So anything that I would use tile sets for would just be for rendering. Again, if we get to procedural generation, then tile sets may be worth more to us. But that means that we come up with procedural generation for tiles at that time. It'll be neat. / collision GLSL. And this will be... There, this is this one. This goes here. Extends resource, which means it's going to have an RID. Okay, but they are auto-release, so we don't need to worry about that. It is just a resource. It is a internally reference counted thing that once it is no longer referenced will go away. A shader file get. Let's what spear-v is. Haven't ever looked it up. Some sort of compiled version. It's going to return a RD shader spear V. What? That, and this is another extends a resource. So then we have our actual shader, so our rendering device here. Don't know if we're actually going to need to release that one. Change you. Old notation, underscore lowercase, indicating that this is effectively private at the level. This is what actually matters. The name doesn't matter, but it is a notation that I am dealing with an internal variable here. It's if at any point I think, hey, I want to make this exposed higher up, I either need to wrap it in a accessor function, or I need to decide, is it actually an internal variable or not? If it's okay for it to be exposed, I can just make it a property or something. But if I should not be messing with it outside of particular accessor functions, or the proper functions, I should not make it publicly available to set. Anyhow, okay, so rendering device dot is, what was it? Shader create. And that gives us a RID. So this is our public override underscore exit tree. Going to be we're done with the shader, get rid of it. There are other places that we should probably be doing that, like for our outline shader, but again, for now. Okay, so we have it. Now we're going to be setting up our input data, and this is where things get fiddlier, and also where things get really convoluted. So let's plot this out. ASCII art can be fun, Key. I come from a time when that was pretty much the thing, was fully rendered out ASCII art was the way of memes at the time. They're still used. It's still very prevalent. It's just it was way more so. in ye old ages of Usenet and whatnot, before the coming of Reddit. Okay, so we now have the shader. We now need to actually load up data. And that is going to be additional markers. So I emits, entity added. Don't. Okay, let's map this out here. So we need to know when entities update their positioning. We don't care about so when an entity moves, message, entity, general, remove entity message has this is the entity to remove. Entity added message, there's some overlap between general and global. Entity added says this is the entity that is added. Then entities themselves have position updated messages. Here. So a position updated message says this entity. Okay, we got this. All right. Okay, so first we're going to track the entity added. That is the window key. That is the window. The window is most the size of the side of a house, but it is accurate. Almost big enough for a stormtrooper to hit it. An entity, when we're getting a collision for an entity, do we have a get entity on our entity manager? Behavior is still part of entity, base entity manager. Now we're looking at entity manager as a whole. Get entity by ID. Okay, we have that. So if we get an entity by ID, whenever we have a change, we're able to check and see. We're able to look at that entity and know whether that entity is active or not. Does entity have a animation collidable. Okay, collidable changed is relevant here. Yes. Come on, where are we at? Oh. Let's check entity collidable changed message. Okay. Excellent. This is part of the reason that I'm really liking switching over to the throw message packets around model, is that I'm able to look at it and say, wait a minute, am I actually, like, do I have all of the data that I might need? And in this case, I do. What was the entity, and what did we change it to? Now, I could have a changed from in this as well. And I have, in this one, I started doing that. Where was it, and where is it moving to? This could be useful under this model. Right now, we're going to brute force, as of this exact slice of time, are there overlaps? But if I were to include the prior position and the new position, I can do a calculation across time and say, are they colliding at any point in time? By doing things that are essentially expand the circle out to cover the entirety of its possible collision space. All kinds of algorithms that we can put in there. For now, we're taking the hit it with a great big hammer approach, and we're just going to brute force calculate everything. We're doing... It's not a terribly large thing that we're going to be doing, technically. Anyhow. Okay, so we need I emits entity added is equal to services dot resolve. It's entity added dot entity added plus equals this, and we're going to call it on entity added. And then in our exit tree, a lot of these sites do react very... As time has gone on, and this is not just like a recent thing by any stretch, over the past like decade, a lot more websites are very attentive to everything you do. Every little thing that you do on the internet is likely to very quickly be reflected in things like streaming sites, like vendors of any kind. Assume that if you take an action of some kind online that leaves a fingerprint that is traceable to you, that information will be turned around to push advertisements of some kind to you. Whether that's by showing you videos and streams you like, so that you'll sit through ads, or that it shows you products that you thought you never did any sort of interaction with online at all. It's like, nope, your eyes lingered on this particular advertisement that was in the search page for this arbitrary thing that you searched for more than like 1.5 seconds. That means you might show interest in that, tempered by the kind of thing that you were searching for. Let's test that theory by bubbling up an ad at this time, or this video at this time. Oh, they did? Strengthen that feedback. So again, we've had machine learning for a long time. People are just now starting to jump up and down and request capital investment by calling it AI. But we have had very effective algorithms at things that language models aren't necessarily as good at for quite a while. Remember, the YouTube algorithm and the ability for you to be serviced an ad or a video related to something that you thought you only mentioned to somebody verbally some time ago, that has been a thing. They have that whole information science thing down. Big Brother is watching and they'd like to sell you something. Which is kind of apt because 1942, the Big Brother in that is often construed to be like a overreaching federal government. But if I recall, it's described as a either potentially as or explicitly as a corporation. I don't remember, but as a company. Not a lot of real difference in the end, but, you know. Yeah, Lunar. The overgeneralizing is leading to a lot of flawed behavior where we're trying to take one gigantic data set and say it's going to be good at everything because, cross your fingers, emergence or similar. The idea that, well, you know, it's got all this cooking data, maybe it's applicable across stuff. And it could be. Or it could suggest wildly silly things because its data set is contaminated by stuff that sounds relevant but isn't. I don't know if we will need more of those, so we're going to have entity. Okay, so when we start up, we're watching for entities added and removed. These are the critical aspects here. Then for each entity, we're saying entity dot move plus equals on entity remove. Entity dot collidable changed equals that. All right, so we want to know when we're getting rid of an entity because we want to detach its events. We want to know when an entity moves because we need to shift its position around in the logic, and we want to know when it changes its collidability. As far as an uncollidable entity, that is equivalent to the, as far as collision detection is concerned, an entity being set to not collidable is the same as it not existing. It's just that we won't detach from that entity's events. So we are going to say we don't care about it anymore. At least collision doesn't care about it, but we're still going to listen to updates about it. And it won't be until it is collidable again that we will mark that. So we're going to take all of these, move them here to this. We are going to move you up to your sibling here. Okay. So for detaching the entity events, we've got this. I'm just going to minus those. So on entity added, we say attach entity events that. Then on entity remove, we are going to go down here and we're going to say detach. So when the entity is being removed, when the entity says get rid of me, we're going to stop listening to its events. We need to Okay, so we have collision data. We need to disable it when we're removing it. And we need to just update it here. So in this in particular, we're saying, consider this entity gone. We're going to have like a 0-1 flag. 0-1, not a Boolean, because it's probably going to be a 32-bit float, just because it is easier for us to pass floats into the GPU. There's a corresponding int that we could be using, but we're just going to say everything's a float wherever we can. We might have some bit fields. But if we have bit fields, they are going to be... Oh, anyway. We'll get there. Okay, so in multiple of these, we are going to have an update to the entity's data, and we're also going to have a so if the position changes, we need to update it. If the entity is removed, we disable it. If the entity is added, we're going to update it again. So anytime we update the full data, we might as well check and see, should it be enabled or not? So we're going to check if it's collidable, and if it's collidable, we're going to incorporate that. Okay. Entity. Oh, I'm hitting all the wrong buttons. Ugh. Adjust posture. Check for underwheel cat. Entity. collidable. All right. So for just updating the entity, we do the full pass on it. It's equal to... Okay, so this is effectively what we're going to be doing here is if it is collidable, then we're going to toggle the field. If it isn't, well, we're going to toggle the field one way or the other. Then wow, that was a good one. So sometimes the autocomplete works for you. Doesn't need the float aspect there, but you know. If it's height. We're just putting these data values in. We don't actually do anything with them yet. And remember what all of the things. We care if it's enabled or not. We care if we care where it is. We care what its shape is. Okay. This is a separate little bit here, so it's going to be say this is where it can get fiddly. So you have a rotation value. I don't want to have to deal with rotation, but if I want to be able to handle things like continuous beams and the like, you know, like a static laser that does damage to anything touching the entirety of the beam, then I need to be able to handle things like a long rectangle that can be rotated. Hey, you. Rotation. Shape type. So the dimensions are very akin to the way that you have to talk to the Godot physics server when you are making a shape. So just because it's a circle shape doesn't mean that I can say, oh, set circle radius. It's all shapes get shape data sent to them. If it is a circle shape, it expects the shape data to come in a particular form. So you're going to say like, oh, the first value is the radius kind of stuff. In this case, it's going to be the same way, is because I have said that it's a circle, the dimensions values will be relevant to that. What this amounts to is either I'm going to have a series of parallel arrays or like one big multi-dimensional array for entity data. Then some of these will be vector 4s. We can bundle them, but it creates some fiddliness with how we would want to do that. So we're going to cluster them where it makes sense. So like the entity position will probably be a vector 4 to have like x, y, and in z of the vector represent x, y, and height. The alpha channel on the vector 4 currently will do nothing. Why a vector 4 then? Because the GPU likes four adjacent floats. It likes its data units to be like that. Ugh. Come here, Sky. Come here. Are you in troublemaker mode? Explode. Okay, so what we'll do is we're going to look at the entity and we're going to say, what is your collision key? Like what represents your collision type? So every entity has a visual key and a collider key. Also has a shadow width, relevant too. But collider key is what we care about here. We're going to go to the catalog and say, give me a collider out of this. And one of the weaknesses is that we don't have... There isn't a core definition of what a collider is, so there's no generic for it. But the assertion with this is that there is some catalog key that represents the data packet of what this entity uses for collision information. If this ends up being the way that we go about things, there probably won't be a collider key. There will be data about collision for that entity. But for now, we're going to have a key because a lot of entities are going to share, like, it is a 8 radius circle is what its collision shape is. Well, every 8 radius circle is the same in that regard. It's not that much complexity. So I would have something that says it's a circle type. Its radius is 8. It has no rotation. That kind of stuff. So in a similar vein to how we have a physics server collidable collider is a catalogable. But everything about it is specific, about this one is specific to physics server manageables. It's just that I can say this is a physics server collider of whatever type in the code. So in that way, here, we're going to have a shader collider. That's iCatalogable. This, and then we do interface, and then we need to have the relevant stuff up here. Category and name. Just so. Then is a shader collider duplicate is equal to new shader collider. Get set. Go. Okay, so that's ready to go. We're going to have a so we're going to make an enum for it, so it would be, you know, shader collider types. To that, and that, that, and that. Okay, so the rotation 3. And an offset. All right, so the offset is when we're determining where to place the actual collision ball based on the entity. So some entities are going to, the collision would rotate around them somewhat. So the transform is going to be fiddly for that. But primarily, this would be, I want to have a capsule encompass it. Let's say I want to have a capsule around the player model. So I think this will still compile. So right now the player's collision is, it's slightly smaller than the shadow at their feet. There's kind of like a little pill shape. But if I didn't want to have like where you are standing is your hitbox, and instead said, well, the sprite is the hitbox, I would draw a little pill shape like closely fitting like a little inside of the sprite for the player. For enemies, you can make it a little bigger than the sprite, but for the player, you don't want the player's hitbox to stick out of them at all if you can help it. But anyway, but if I do that, if I make that capsule that way, the bottom of the capsule is going to, like its edge is going to be at the feet, but the position of a capsule shape is generally where its center is. So the offset is a way to say, wherever the center of the shape would normally be, adjust it by this much. So that's what rotation falls into. For now, we're not going to get into that. We're not going to get into rotation and offset too much in the code. We just want to get type and dimension in. Oh, let me quick check for the syntax here. Removing the flash banging here. Okay, close. Some languages are fiddlier about it than others, or have different patterns for doing it. Hey, Denizen. Welcome. Circle is equal to million. Okay. So now I can use shader collider type to fill in type here. But it is a float. It is not this particular data value. It is a float. Enums can make things fiddly in some places. I'm just going to say, no, that's a... Actually, we're just going to use it as a float. It'd be nice if it would let us go all the way with that, though. Okay. That is useful. Okay, we can't specify that. Okay, that's fine, though. Yeah, we're only passing it in that way because we are going to ultimately be very stringent about how we structure the data. Yeah, back massage here. Oof. I just got dive bombed by one cat who just decided my headrest was an intermediate point between 4 feet above my head and the ground. Sherbet is very nimble. Day constant climber. Okay, so we have all of our type data. So we're going to look at it in here. The entity does not have proper shape data. We want a fail case. For the time being, though, if we look here, we say 1 and 2 and 3. So it would be catalog. Slider is equal to catalog dot get catalogable entity dot collider key. If it is the wrong type, it will explode here. Duplicate type. One, two, three, offset. Just real quickly here, where's our duplicate? Yeah. Okay, so the base one has to do this. So we are going, careful, Sky. We need to do that. Explain what this is doing in just a moment. Okay, so duplicate is a cascading copy. The topmost child here, so the one that inherits directly from catalogable, says, I will create a copy of whatever I currently am. So if it is a child class, it is creating a copy of the child class of Shader Collider here. It is creating an instance of that, but it is casting it into Shader Collider. So whatever the thing actually is, cast into this shape, and we are returning it. The general pattern is that you say, in duplicate, you say, the thing that I am casting it into is equal to base duplicate, and it will just hop it on up the whole time. Since it is created as whatever the child class is, its actual data shape is the one that you want. and each layer is treating it as what it is and sets the corresponding values. There is some fragility here, is if you break the chain, it breaks the code, but if you break the code and you're the only one writing it and everything is following that pattern, it's your own fault. Code conventions are whatever you make them. If you can't stick to conventions that you are the only one responsible for, then it's your fault. Okay. So we have that. Okay, so we're going to have our data structure is currently going to be whatever we decide it's going to be. So for the time being, it's going to be the simplest way I can do it. We are going to have a series of data values here. Which will amount to a set of one float, so an array of one float, an array of vector 4s, and then another array of vector 4s. Why vector 4s? Because it's going to make me stack them properly anyway. I can probably do vector 2s, we'll test it. But we just need to be aware they might need to be vector 4s. I could just make these independent floats. We'll make them all floats. So we're going to have a series of arrays like this. So it's going to be 1, 2, 3, 4, 5, 6, 7 arrays of floats. And they are going to be max entities in size. We are going to set max entities smaller than that. This doesn't matter anymore, I think. Actually, no, it is using that. We're not going to actually use that for long. Anyway. Okay, so we have a... bot. Entity manager dot max entity cache size. That is something that will move somewhere else, but for the time being, we need to. We do it there? No, too bad. These are all predefined. These are not small data structures. In the... from high up, they are tiny data structures. Keep in mind, we are having 20,000 4-byte, 32-bit floats. Which is not a huge number. So let me just napkin math here. Oh, let's see here. Then we're gonna 2 megabytes. If we were to take the entire data structure that we're talking about, we're looking at potentially a gigabyte of data. And that's, again, if we assume 20,000 as our limit, then we would also be looking at, probably be times 8, actually. Do that again. It's probably going to be... There's a lot of, like, compacting we can do here. Let's do some... We're going to do some preemptive work on this. We are going to use... All right, we're going to do a series of... This is a Boolean. This is a Boolean. We're going to compact this as much as possible. We need to be careful about how much information we are actually throwing into the GPU. We're going to be using a storage buffer, which isn't... This isn't meant to be data that we're going to be changing a lot of constantly, but we're going to have to load all of this. Well, there's going to be enough of this that we need to be very cognizant of how much space we're wasting if we don't need to be using it. Okay, so then we have... You look at this, this actually has a nice... If I put float here, it'll complain. Let's see here. We can probably condense a whole lot of this down. Okay. We could use bytes for quite a bit of the raw data. It is an int. It is an int. Okay, technically it's a float, but if the degrees of rotation that you need to use for this is that fiddly, we're just going to keep it afloat. Same with these. Technically, all of these could be float values. Same with that. So we're still good there. But type and collidable are going to be very narrow. That doesn't save us a lot, but it will save us some. Okay. Let's copy this over, and now we can just copy this one two more times. Say 2. No. Oh, this will save us time. Oh, no, it won't. It won't. It won't. Okay, how do we want to do this? So data structure wise, I don't want to have to keep copying the shader collider for each one. No, okay, these are fixed. These aren't changing. For now, once something's collidable, like its shape is determined, like if it's a circle, it's always a circle. If there is some part of an entity's life cycle that would cause a different shape, that is a different thing. So if you use modifiers to make, say, like the homing mouse explode on impact, the mouse does not suddenly become a bigger collision zone on impact. The mouse goes away and an explosion spawns there. And that explosion has its own shape. If the mouse periodically emits a laser beam, then that laser beam is its own entity with its own collision shape. So work from there. We work from there. Thinky. We're going to be moving a little bit more slowly next couple of days here, you know. Getting through all this. Okay. These are the fixed values. Is it collidable? We also need offset. No, this needs to be a pair of floats. Same thing here. This is offset Y, and they are this. Now, I may be able to make a internal structure in the shader that accomplishes this. That is such a pain, though. I was mentioning it is the structure and size of the data matters when you are passing it to the shader. If I'm passing it as an individual buffer, each buffer looks like this kind of thing, then I don't need to worry about the allocation of each one. I'm going to take some bytes and say they are this thing. You know, these are floats, these are bytes. They come out the other side and are floats or bytes. If it is a data structure, that data structure effectively needs to be packed properly. So you need to know how to get your data to fit into, and I think in our case it's 16 byte chunks. So a float is 4 bytes. A 32-bit float is 4 bytes. And then shaders, by default, like the core of their original existence is graphical. So they deal with vector 4s, a 3 float value color and an alpha channel. So your RGBA kind of pattern. So they're set up to take packets, like packets of data in that size, vector 4, vector 4, vector 4 kind of stuff. So you want to squish everything into that box, and that gets wonky because then you're making choices. Well, how do I get clusters of 4 to line up? I may still need to do that to get it where, like, okay, this is actually an array of vector 4s, and these are 4, and these are 2, but that also means they're 4, and then these are that kind of stuff. So it's collidable. We have a float. Really tempted just to ignore height in this so I don't have to pass it around. That will still register the collision and then we'll look at it after. I think I'm going to do it that way. So I don't think we have to worry too much about the packaging for it to be different here. Okay. So when we are initially loading the entity, we're going to get this out of the shape. So this should probably fail, but it's also possible that we just have a bad collider in here. If I want to have... We're going to let it explode. Okay, so it is going to be this battery of stuff. Okay, so that's going to be... Header dot type. Set over to a byte type. Operations entity.id. Really be an issue, but we're going to be doing this potentially many, many times. So getting the IDs stored off to just make small changes. We might be micro optimizing here, but we're dodging one operation each time. D is equal to collider1. We is equal to collider dot offset dot. And sometimes, like, why? That is an odd suggestion that the autocomplete was making. So first, when an entity is added, we are going to update the data here with e.entity. So first we get its shape data, then we are going to update called just update entity. So the shape data is something that we're pretty much always going to do. We do when we add it. Update entity we're going to do pretty much any time the position updates, collidability. Hey there, Laura. Welcome. We're setting the groundwork for our, hey, let's do brute force compute shader collision again operation. Flags e.id is equal to entity collidable. It'd be that way. Collidable in position get updated when we update the entity. e.entity. Let's change the collidability. As an anti-B, comma, collidable. Collidable. So whenever we update entity, but that is only when we are, this is the only place we call that. Otherwise, we're updating it manually into, so we have shape data. So we can actually just say update entity position. And set entity. What? Oh. Dot ID, comma, e dot entity, collidable. Okay, so when an entity is added, we do shape data, position, and collidable. Then we update the events. When collidable changes, we set collidable. When position updates, we update the position. When it's removed, we set collidable of e.entity.id to false. And then we detach the events. So this will remove collision from it if we do this, but we are going to, for the time being, let's do an interim commit here. Interim commit. Yay. Just getting all of these little commits stacked up. That's what version control is for, so if I blow up more than what I'm working on here, I can go forward. So if I go into services now, and instead of the collision manager, where did I put you? Oh, that has to be in the Godot side. Oh. This might be an opportunity to change this. Okay. Add scoped. Say collision manager. Okay. So we're saying that when you ask for a collision manager, get a shader collision manager. Currently, in game, we are getting that from a packed scene. Does a collision manager have anything that is exported that I need to worry about? It does not. Good. Okay. Stuff and things. Game. It's a bit of a mess in here. So right here, add child. We are going to say services.resolve. And first, to make sure we don't blow this up, we are going to have physics server collision manager here. Yep, okay. Okay, the door did not appear, and I did not go through it. All right, let's see what the errors were. Ah. Okay, so some of the things were immediately exploding here. We need shader colliders set up here for all of this. Some of these weren't able to load properly. It's surprising that any of them are able to load properly in this scenario, but we know what the problem is. So for this, I need data. Explorer, data folder, colliders. Shader collider. We're just going to go with circle first. We will need to make sure that the shader collider is set up to have all of this. So it is a type of circle. Dimension 1. And we're just going to say everything is a circle 8. Doesn't have a rotation, doesn't have an offset. Might actually have to look at the offset differently to get this working. I think the offset is actually stored somewhere else. Change data. It's entity. I know visually they... Oh, okay, yeah. Visual offset is how we do that. We don't do a shader offset. Oh, good. Okay, that's nice. Goodbye, offset. Like a whole lot of floats that we don't need anymore. You visually offset them because visual has no real impact on the world simulation. The collision space is, for all intents and purposes, where you actually are. Doesn't matter if the image is high in the air and it's just a tiny shadow. As far as the world is concerned, you are wherever your hitbox is. So it's the hitbox that is going to be at the true position of the entity. Okay, so we have shader collider. It is currently a circle. It has all the values that we should need out of it. So then we are going to go into our bullet and our enemy. For now, we actually just need the bullet in the player. Circle. Also the door. Okay, there was an error. Wind up mouse, player, and door. Let's do a quick catch here. Okay, so the player, the door, let's do that again. Lighter shader circle. So for the player, we have collider circle 8 coming in for this entity. Because the door isn't defined inside of that. It's defined inside of the level, which lives here. And the reason that we started in the wrong place because of that is if the door doesn't exist, there is nothing that hears the passage being exited. There we are. Now, if we walk through stuff, nothing happens right now. But now if we go in and we're going to mark entity position updated here, that'll immediately happen. So we have this entity, which is an arbitrary one. This looks like an indication of which one it is. Okay, it's the one of the wind-up mice. So its ID is 2. So if we're looking at this, which is our collision manager, we're looking for, let's say, types. So you see how most of the stuff is 0 here. There's going to be a lot of zeros. And the first X of them are type 1s. Then if we look, our rotations are all 0. None of that's coming in with that value. Our X and our Y, so it's 2. So we have 467. Step into, so we're here. So 2 is 467.66, So if we look at our entity and its position, so 468. Oh, that's why. That'll cause a problem very shortly. That's the wrong constant. So it's 468, and we just stepped over that. So if we go back up into our cache here. Yeah, okay. Is dot max entities. It is a much different number. Okay, so we are recording the information now. This will give us access to that, and what our next set of steps is ultimately going to be is getting it into the shader. So we're going to set up a bunch of stuff akin to this, where we have, oh, this is an array of floats. It'll look more like, do they have it defined here? So I'm defining a buffer and saying, oh, it's floats of this. I will probably have a variable that is passed in, potentially is just like a pushed uniform. Hey there, APOC. Welcome, welcome, everyone. Welcome. Yep, compute shaders. So, some quick background on it. We are, well, okay, let me put this back so that we can see the shenanigans. This will be a physics server based. Okay, well, we can't. Bear with me. So yeah, what we're going to be doing is we're going to move our actual collision detection out of using Godot's built-in physics and into a compute shader. We tried this before. It was kind of we didn't do it right, but what we've learned a lot since then. And we've looped around. So we started with pure GD script. Performance wasn't ideal. We want to be able to have... I want to be able to shoot for 10,000 things on screen at once. But there's a lot of tricks for things like bullet hells and whatnot we can't use. I can show you some of the behavior in this at least. I can't show you the collisions because those be broken right now. So nothing can hit anything. I can walk through this little teleporter and nothing happens. This is the bullet we're firing. It is a projectile that locks onto a random enemy and homes in on them. The mechanic of the game is not that you get different weapons or you just level them up. It's that you socket in upgrades to them. So now it fires 3 times a second. Each of them being clones of each other. So each of these is following the same target at the time that it duplicates itself. It splits into 3. So it's 3 times a second and splits into 3. It splits into 3, but after 3 seconds. So you'll see them burst apart later. Splits into 3 after 3 seconds, and then tries to move to orbit the player. Oof, game in. Okay, yeah. So that's one of the things I've discussed. It's game engine as an exercise and as a tool to do what you want is cool. A notable variant that is there and is actually part of the inspiration for this is a game called Noida. Noida has a custom game engine because none of the game engines that are commercially available work for that. But an actual custom game engine is that's a big undertaking. It is a big undertaking, but you can do stuff. We're using Godot At the rate that we're going, Godot is largely becoming the rendering engine for us. Like, quite almost literally, these are sprite nodes. Eventually, I might be rendering them in shaders too. The little black outlines on the sprites are because of a shader. They don't actually have those outlines. But for the most part, all the visuals are handled in Godot. Everything else in the world is C#. Like putting all of the parts together. It's one of the nice things about going down this road is that if I decide to hop engines, I'm going to be able to peel more and more apart. Well, thanks, APOC. I appreciate it. Yes. So there was a period where the rendering was multi-mesh. If they have added further to that, I might be able to revisit it. The problem is that multiple multi-meshes, well, it gets real fiddly real fast. But again, we might revisit that. I believe the problem that we ran into is I want to be able to more easily incorporate variably sized sprites, and Godot's multi-mesh isn't terribly friendly to that. But there's footwork that could be done. Since I'm... Again, like... This exists in the game tree just to have a root node. That's all it does. Does it need to? Technically, no. A lot of the stuff is that way. Oh yeah, we did this before. We're revisiting it because... I didn't show you why we want this many. I need to be cautious about this. I don't think I'm going to get an overrun doing this. So far, I mean, given that Godot is kind of is effectively a community, like it's in the neighborhood of open source kind of stuff, in the vicinity. There are bumps in its like movement and inclusion of stuff, but so far it's reliably moved in good directions. All right, so this is what I call a calamity case. Sitting idle with nothing really happening, we're getting between 2,000 and 3,000 like frame updates per second. There are 4 entities in the world, the player and 3 projectiles. We are going to take that 1 projectile per second and have it fire 3 times per second. It will split, each of those projectiles will split into 3, 5 times, and then they'll try to orbit the player. I've got orbit the player because it is expensive motion. There's a lot of extra math. Okay. I just want to make sure if I go over 20,000, there's going to be like a hard error. But it doesn't look like we will. I would need to add a little bit more to get over this marker. Do I have something that would do that? No, okay. But, I mean, this is sufficient to give you an idea of what's happening. There are about 7,200 objects. With the optimizations we have already made, we are getting about 13 frames a second. The game world simulation is set that no matter how slow it gets, it never calculates faster or slower as far as like time passing in the world than a fixed number. It is always that number. So even though it is chugging down because of the number of things we're doing per frame, you can see a couple of aberrations that were happening there. There are some known issues. But we have this. There's a whole lot of other stuff that we want to be able to do, and we've started doing it, but the cut over to this is because of that red dot. This is the reason that we're returning to the compute shader. Because when I touch that red dot, it's supposed to teleport me here. Just move you right there. There's a lot of song and dance happens in the background, but it teleports you here. But it does it twice. It's not supposed to do it twice. It does it twice because Godot physics handling happens before the code bridge happens. So there's the physics process that is the step. So you have process, which is like the visual frame update. Physics process is the as stable and like consistent as possible, like systems update. Again, movement physics process step. Just before that, Godot calculates all of the collisions, like before that step happens on the subsequent frame. That is using a snapshot of the state that is supposed to have been what the state was at the end of physics process in the prior frame. But if I directly move things, like I take an area or a body or something like that, and I say, you are now over here. Again, if I teleport from the red dot to here, I say your position is now this. Cool, but in doing that, I have changed that snapshot, but not using Godot's automatic physics system, the move and collide, move and slide kind of stuff. And apparently, it can be off by about a frame when that happens. So as far as Godot is concerned, on tick 1, I touched the door. So the door ran into the player. It's a decision that I made. The door hits the player. Players don't hit anything. Things hit the player. The door hits the player. And as a part of the handling of that in the subsequent physics step, that collision gets turned into okay, move the player down here. So the player's position, both visually in data and as well as in the physics system, their hitbox, is down here now. But the snapshot doesn't seem to have gotten the message. So at the top of the next frame, I get these two things collided. These two things that are like 10 hitboxes of those things away from each other collided. Could I fix this? Yes, I could put workarounds in place for it, but the nature of that means I am fighting the fundamental way that the physics process works. And for me, it's better to say, then I won't. I'm a go over here. So Godot is, again, rapidly turning into our graphics engine. Would I be able to immediately port my stuff? No, but I'm approaching a point at which I would have things like Godot-specific libraries. But we can see, now that I've been sitting here for a while, we're back up to about 2,000 to 3,000 frames per second here. So there are some leaks. I know there are some leaks. Ideally, the more I moved away from it, the better. I tried a physics plugin, but that was like so many iterations ago. Where we are now as far as code base is a different dimension than when I tried Rapier, I believe. I don't have any of them loaded into the level currently. No, I might as well. Let's have fun. Okay, we're gonna go here. We do need make sure all of this is set properly. My source control does not have good commit messages. My source control is primarily a, oh no, what have I done, undo, undo, undo tool. Okay, we're going to still need collider shader circle put in here. And we are going to have to put the blob in there with that. So we're going to discard those changes. We go back into here. We're going to reload it. I'm going to do that. But that also means we need to find the blob. All of my data structures are in CSVs that will be turned into JSON at runtime or in raw JSON, which we'll just process. Part of the data structure methodology is to make it mod friendly. I don't have a mechanism for like adding scripting in, but if you would want to do things like make custom levels or enemies or similar, there will be options to do that with relative ease. So they won't collide with each other, and it'll look wonky here when this happens, but... We load the level, the player appears, they enter through this door, which spits them out here. There is this enemy that appears. It is a spawner after about 3 seconds. It triggers 100 enemies to appear, which converge on the player. Right now, that enemy movement is determined by draw a line to the player and move at them. We are going to be changing that to a flocking-like behavior, but let's say that what I'm doing right now is a run-up to the way that I'm going to handle walls and walkable space and enemy movement. Because that's another thing that I want to save time on, because Godot pathfinding is right out. That is way too expensive, and Godot physics wall management is right out. There's no way I was able to do that. And I don't want to have to create a whole bunch of arbitrary, like, this box is at this angle, at this point, in my levels. So there's more shader shenanigans that we'll be doing. Let's see here. I think there's still more that we can accomplish today. A couple of things here. Okay, quick break. We're going to get a little bit more done today. Be right back. I'm back. And yeah, James, we have circled back around. So I spent a good portion of time over the last week kind of kicking this issue. Well, looking at the door logic, and I discovered a physics issue. And this has... I mean, it's not a table flip moment, but it kind of feels that way. So we're getting that set up again. Going to see if, lessons learned will help us. There are a couple of things that we were doing with the compute cycle that weren't good. We'll just kind of have to hammer at it a bit. I've talked about how we're going to do room navigation and floors and whatnot, and that shaders will be involved in that too. Walkable surfaces, I should say. So this is... It's a tangent. It's something that wasn't in the current path, but we have to go a new road we have to go down. But it will at least serve as a good kickoff to doing still more shaders. Okie dokie. We need to set up our buffers here. I have that opened. It's you and you and you and you and you. And we'll leave that and we'll go over here. Okay. Now I don't want to save the web page. That set up. It's going to be effectively this. I'm going to pop this down in a function right below this. It's not going to just be in this one method. We're going to have like some repeated definition of things. After, I think. Right? Yeah, after that. Okay, so for set binding 0, then it's going to have each of those. We're going to have a whole pile of these for now. We may tune it to have it be single data structures and say, hey, I'm going to mess with just this one. That, again, gets us into memory structure management. And that's... I want to dodge that for proof of concept and get into tune and tune and tune, because we kind of need to go this way. All other roads are exhausted. Down here is where we're creating our storage buffers, and those live in must be released territory. So we're going to have a series of these that we'll set up. Uh-oh. Oh, okay. Saw a hiccup in one of the chats. Verifying nothing. YouTube doesn't think anything's on fire. Where we get the results. And this is one of the steps, is the subsequent physics frame is when we're going to be doing this. Our event structure is set up to make it easier to do this time. He said, We're not going to wait for a sync. We're going to sync the next time we get a frame. Which will be, what we're going to do is we're going to give it at least 1/60th of a second, potentially more than that, to get done. But we're going to see how that goes. The more frames per second we give ourselves, the more physics frames we have that we can wait and say there won't be a game state update during this time, that's fine. We just need to determine kind of what the sweet spot is given how much work we're putting on the GPU. All right, so we're going to create input buffers that are bytes of these. We are going to create these arrays in advance because they are known sizes. That way we're just copying into them. We're saying take the contents of this and copy it in. We could further adjust this so that we're always just updating this. We'll cross that bridge when we get there. Is that hard? No, but it's an algorithm, and I would want to plot that out. Short version, what we've got is we have the raw data collection. We have this. We are going to predefine this. There's no reason to reallocate this over and over because this will always be here. Right now, we're going to be doing this operation of copy the contents of this into this one with the understanding of. What I would like to do is if I could get these to be the same thing. There is a way to do that. I just have to find it. Is to say this address that these both point to, in this form, it is bytes. In this, when I reference it through here, it is a float. If I have that, then I am just saying this is the buffer. And we will load that buffer in each time. But what we want to be able to do is not have to do these copies. The less time we spend messing with memory on the C# side, the better for keeping this clean. It means we won't be wasting memory space. It means we won't be wasting time duplicating data from one into the other. Modern processors, even on a phone, are pretty good, but that doesn't mean we need to do it over and over. I think we can get all of that defined. We'll have to see exactly how this will end up working. For the time being, we're going to have it do nothing. We want it to send out, and then we're going to get the data back. We're going to look at those output values again and make sure that they come out the same. That's going to be our starting point. Is I just want to take the data that we put in and treat it as like an output buffer. Maybe like change a couple of things, like maybe the first value gets changed or the last value gets changed each time. If we just do it once, if there is a single work group and a single local group, so ones across the board, then it will have one iteration, and we can take that data value and we can mess with it. I could have have sworn there was a way to do that. Let's see. Yeah. Can we get away with that? Just doing some quick Googling. We do that. So I'll circle back to that. There is some song and dance you can do to essentially create a pointer to a space in memory that is identical to another. So I could say I have a span of integers and I have a span of bits. They are the same space in memory. So if I mess with the span of bits or the span of integers, the other one reflects the changes. In C, C++ kind of territory, that is kind of a foregone conclusion, since you allocated the memory, you have a block of memory, all you're doing is messing with the block of memory. If you say it's an integer, it's integer shaped when you talk about it, but you can also say, oh, but it's a float. That's what casting is most of the time, is you're saying take this thing, but view it through this lens. In some systems, that can cause a type conversion. You can have a kind of an equality operation that will make a value out of it and say, oh, here is the number that you mean. But in some cases, you can say, oh, that Boolean output it as an integer, and it just looks at the bytes, the actual data, and says, oh, if I interpret this as an integer, that's the result. We want to be able to do that by saying, this is memory, and I want to mess with the memory. We'll see. For now, we're going to brute force it. So we are going to do a series of buffer creations here. So we want our byte arrays to match this. This one's okay. It's already a byte array. is going to be, well, here, we'll copy each of these since we're just going to change the name a little bit. We'll change more of it, but we're just going to iterate over this a little bit. Again, brute force, not pretty. Some of that copy paste work wrong. This new byte. I could duplicate some of this stuff and make methods for spitting out a thing that's the size of a thing based on a template, but not gonna. Now I could have a nice little templated method for spitting out a array of this size kind of stuff. Maybe I'll do it for a static method, but for the time being. Because this is a lot of duplication, you know. Okay, so then you're going to have a series of actual buffers for these. So rendering device storage buffer create. And that is going to be what? Is it RID? Okay. D buffer. These are resources that we must free when we're done, which is why we need to store them off. These should all be protected. Technically, they are based, well, they're private based on what I'm doing. It's not what I intend to do, but go paste in access level in a moment. Okie dokie. So each time we create a storage buffer, it will be the length in bytes, which is a known, and the values that we're putting into it. Checking, is there... Okay. All right, there is a buffer update method, so... So we're gonna keep ready where it is. Did RID create buffer from byte array. What? Every now and then. Buffer. Rendering device. Underscore rendering device. Storage buffer create. And we are going to say this is as a uint. This is data.length. Create length and data. Yeah. Unit, uint. Okay. So that gives us a create. We're also going to have a buffer byte array data. And that is zero dot length assigned integer data. Again, these are all fixed length. We don't need to worry about that, but this lets us update the buffer. Hopefully we won't need to worry about too much of this, but those are all created, so we are going to set up our buffers now here. Buffer is equal to create buffer for types. Dimension 1. This is all dreadfully familiar. And we need collidable flags, position. Checking. Yes, okay. So here is our... So these don't change frequently. Okay. These definitely don't change frequently. Unless an entity type changes, we're not going to need to update these very much. That said, it's likely to change a lot. But like moment by moment, until that entity goes away, these don't update much. This one is unlikely to update. Most of the collision shapes don't rotate. If the object rotates around, it should probably be a circle in most cases, but it could. But for the most part, what we're going to do is we're just going to treat this all as one big data block. Here you go. So we create the buffers, and then when we are exiting the tree, we are going to go through all of our buffers. I'm just going to nab these as a reference. Rendering device dot free. It builds. We run it Godot to make sure there aren't any invisible errors. Godot reports some things that won't actually err on the C# side because of the level of detection or buffering that is in, or kind of the level of safety net that exists. I don't know how to put it. Okay, on entity added, we remove entity added on entity removed. So we've got all the entities song and dance set up here. Okay, so this messes with all of the data. Then we're going to be looking for... So we have a key one in here that is a protected Boolean. So there's some extra wiggle in this that this is essentially going to create an extra step in the game state. And that's that not only do we have to wait a fixed number, like at least this much time must pass before another physics step, we also need to say whether we are delaying the world to let the physics get done. So we might need an event for this. For the time being, we're actually going to make this a public. Here. If we are waiting to sync, we do not do the next step. And it's during... We're going to give ourselves game ticks, is what we want. Huh? Oh. So once we kick off the shaders processing, so we get a game step end, we need to have a physics step to process. And if in the physics step we trigger waiting to sync, X game start steps later, it has to be at least one. We have to get to the next one. So let's get that in there. Emits physics step, emits physics step. No. Services not resolve. Okay, so we have waiting to sync here. If world physics isn't ready, then we don't proceed into the rest of the setup yet. We may have to look at our events because with physics there, does entity care about world start? We have end and we have time passed. Let's world start. So we're activating, it's configuring. Entity manager uses world start to purge entities to remove. So what we would have given this pattern is remove anything that was queued to remove, do collision checks, interact. I think physics step should be before the world start. Let me ponder on that some more. Okay. Okay, so physics server, the physics step is when the physics server does its calculation. World physics says, do the thing. So we would need a time before that we would decide it's ready to go. It should be during the world calculation, but what we could do, because what we're waiting until we get the data. And then during the physics step, we do stuff. The physics step could result in entities being removed based on what happens with them. And because we have made it so creation of entities can be instantaneous, they can exist leading into it. So they will have their whole turn no matter what. They'll be usually created during time past. We will enter into the next step at like world end, and then we'll kick off the next physics calculation. Then we'll come up to the top where world start would remove things. First, we need to do the physics step. So physics step, then world start. So if we are waiting and I get physics step, so we... No, it's at the... We don't care that time has passed for the game. We care that it's a start step. We get start step, and the physics server looks and says, am I waiting? If I am, has enough time passed? If it has, then we're going to sync the GPU. Okay. So we care about world physics because that's when we're going to do stuff. Game start step. Solve. We might need to change this to some other method, like maybe it should be during time past. But this is much more of a status update that it is technically okay for it to be independent. Could we do this in its own thread? Yes, but we will cross that bridge if we get anywhere near it. Again, that is dangerous territory, threading stuff further. Okay, so game start is when, like, is the top of the frame where we're going to be asking, am I waiting? the moment. Did you... we go. There we go. Okay, so in the physics step, we would say we're waiting to sync, and then ticks to sync here is else ticks and sync plus plus. So we have to have one full game step. It is this is a second frame needs to happen. We could say just waiting to sync. So the subsequent frame, we're going to say it gets an extra frame. This would slow the simulation down a lot as far as physics calculation is happening, because the world step cannot start if we are waiting to sync the physics, because the physics step is the beginning of it. This would change it from being we would have an extra layer here that ideally the physics, the collision manager is the one saying physics start, so that the world step can actually start. But we'll figure it out. The higher this goes, the more frequent physics frames need to be able to happen. Because otherwise we will run into issues. And now, keeping in mind, these are game frames, game start frames. This is as fast as physics steps can possibly happen. It is independent of the world ticks. Okay. So let's just check real quick here. What else do we got? I think that's a good stopping point. We have the basics for where we're going. Next thing will be actually implementing the load up of it and triggering of it. I just need to get the data to the shader and then get data out of it. Part of the reason that we want to be cautious in creating this is that the output array is very, very big. The output array is 32 times bigger. Well, the output array is going to be a series of integer IDs, and it will be 32 times bigger than the max number of entities. So we're looking at 640,000 integers. They don't have to be full integers. That we could crop that down into like bytes or something like that. It'd have to be bigger than a byte. Maybe like a short or something like that. But again, with this, we're dealing with memory allocation shenanigans. But it's a great big number, and the intent of it is to, and it doesn't have to be 32. It could be like 16 or something like that. Whatever that number is, that's the maximum number of collisions we can have. Plus one, with the first one being how many collisions with this entity happened. That output one should always be considered cleared, or should always be cleared each time. But yeah, we'll set up the shader, we'll start using it, and then we'll start filling in actual logic inside of it, where we break apart the collision pairs and do checks against them, slicing it into work groups and local work groups, that kind of thing, to speed it up. But yeah, progress. Hope everybody had a good time tonight. We did have a couple of raids. Let me double check that so I can thank folks. Alkaline and APOC, thank you for raiding in, and all those that came with you. Also, thank you to Key on the Twitch side for the the chain views. I wish I could see that on YouTube just as well. Thank you, everybody, for watching. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment, all that good stuff. Most of those buttons are good, so I would appreciate it if you press them. If you'd like to consider financially supporting the channel, you can do so through platform-specific means, as well as additional options that can be found through the link tree that is in my profile and video descriptions. With that said, I hope the rest of your day is good, and I will see you next time. Buttons.